automatic strawberry flower and detection system for yield prediction with minimal labor and time costs. This study was conducted at a strawberry farm in Florida, USA. Strawberry growers in Florida suffer from a lack of efficient and accurate yield forecast for strawberries, and it allows them to assign optimal labor and equipment, as well as the resources for harvesting and transportation, marketing. When growing strawberries in Florida, the production yields can vary greatly from week to week, and weather fluctuations are one of the main cause of this phenomenon. Due to the drastic fluctuation in weekly yields, strawberry growers need to monitor the fields frequently in order to schedule proper labor and equipment. Usually, the number of flowers and their distribution are estimated by humans, which is very time-consuming and labor-intensive. Using this system could provide accurate counts of strawberry flowers, which can be used to forecast future yields and build distribution maps to help farmers observe the growth cycle of strawberry fields. The objective of this study was to develop an automatic near-ground strawberry flower detection system based on UAV platform and the faster RCNN detection method. And this system was able to detect, locate flowers and strawberries in the field, as well as count their numbers. With the help of this system, the farmers could build flower and mature fruit maps to predict yields quickly and precisely. This system used small unmanned aerial vehicle. The UAV used in this paper is a product of Chinese company DJI. In recent years, unmanned aerial vehicles have been widely used in agriculture remote sensing. Drones flying height can be controlled within 0.5 to 500 meters, and so it can get closer to the ground and obtain higher resolution images. So UAV is suitable for this research, and after UAVs take a photo, a computer task called object detection deals with image dividing and recognition. In this process, they used a faster region-based convolutional neural network. One of the latest, it's one of the latest deep neural network model, and it was chosen for the detection and counting of the number of flowers, mature strawberries and immature strawberries. It has also been used for obstacle detection, which helps robots or vehicles to locate and track their position and work autonomously in the field. It's also proved the RCNN was suitable for real-time system due to its high accuracy and low computation time. And UAV is equipped with a red, green, blue camera to capture near-ground images at two different heights, 2 meters and 3 meters, and build an aerial photograph of 402 square meters strawberry field. And the global the flight images were taken every 2 weeks around 10:30 a.m. to 12:30 p.m. from March to the beginning of June in 2018 for training and testing the deep neural network. And in order to accommodate different weather conditions in the deep learning detection model, images were collected on both cloudy and sunny days. We have to prepare in order to identify objects in images using deep learning, such as faster RCNN. The locations and classes of the objects need to be determined first. Faster RCNN requires a bounding box annotation for object localization and detection. And annotations of 3 different objects were collected using rectangular bounding boxes as shown in this figure. The right one in the middle of the picture, right one is it shows mature strawberries, and the yellow one next to blue one, it shows yellow immature strawberries. We also have to prepare a lot of images to increase its accuracy. The images were labeled for training, and its total number was 12,526. They used the Pix4D software to generate high-resolution auto images. Pix4D is a developer of cutting-edge software that converts images taken by hand or drone or plane into survey-grade accurate styles. And auto images is made from photographs taken by UAV. In this case, A is the point cloud model of the 3 meters height image set, and B is the 2 meters height image set, and C is the mesh surface model of the 3 height image set, and D is the 2 meters height image set, and both are made by Pix4D software. They used a faster CNN model trained by the images from March to early June to count the flower numbers in the images. We manually counted, they manually counted the number of flowers in the field before flying the drone to capture images, so that manual count could be compared with deep learning count. And here is its result. This left one is manual count and deep learning count, and right bottom is average accuracy. It shows 84%. Here is the discussion. The quality of all the images mainly depends on the quality of and overlaps of aerial images. In these images, the frontal, these images, the frontal overlap is usually 70 to 80%, and the side overlap is usually no less than 60%. And detection for flowers and mature fruit worked well, but immature fruit detection did not meet their expectations. Sorry, I should have put detailed information on this graph. But this research says the shapes and colors of immature fruit were sometimes very similar to dead leaves, which was the main reason for these results. Thank you for your listening.
Do you think you can use this technology for different crops other than strawberries?
I think it can useful because the price of drone is becoming cheaper, and most of other advanced machines is usually, I think, expensive, but the drone is becoming cheaper, so it becoming useful. Okay.
In this research, drone can just count the strawberry, right?
Yes.
But like after that, people harvest by themselves.
Yes. After drone took a photo of strawberries, and computer deal with the images, and people take strawberries and count it manually.
So, what is the good point benefit for people to use that technology? Because finally, people have to harvest by themselves.
So in this research, people take strawberries by themselves, but it was done to compare the these accuracies. So finally, computer will distinguish these status, and people don't take strawberries.
I have a question. I just want to know, like, why did you choose this topic? Is this your field of research that you want to do in the future?
Yeah, yes, I am a little interested in this topic.
Any other question? You have a quick comments. It's very interesting. It's like neural network. But in case of like the lighting, 10 to 12 hertz all the time. So do they report about like radiation of sunlight? Yeah, that influence.
Photo in both cloudy and sunny days, but I don't know the weather, how the weather influences the results. I will try to search it later.
Thank you. Any question? This is all. Thank you from this group. If there is any question from Kyoto.
Okay, 今日出ります。
Hello, I'm Amami. I have one question. Why did they use strawberries and not any other crop?
I don't know, but in my opinion, strawberry is very small. So if they can detect the strawberries, and they can detect any other vegetables, but it's just in my opinion.
Thank you.
Thank you.
Anyway. Hello, my name is Junya Sakta, and I have a question that is it possible to introduce the greenhouse strawberry? Because I think a lot of strawberries are grown in the greenhouse, but the drone sometimes have difficulty to fly inside the greenhouse. So is it possible?
This is I'm not sure, but drone tends to be influenced by wind, so we can control drone by GPS precisely. I think it's more useful because there is no winds in greenhouse.
Thank you for your presentation. Can you show me slide number 8 or 9? Okay. When you see this data, what do you think? Which is better, manual count or deep learning count?
I think it's not better because if it's 84%, at the end, after this UAV flying, people have to check the strawberries again. So I want it to be more, it to better percentage. I think it's not better because people have to check vegetables again.
Okay, thank you.
Thank you.
Just one thing here, this page, table and the caption is below the actual table. Right?
Sorry?
The table caption, table caption, title. Table 1, comparison between manual count and the deep learning count. Table caption.
The caption is down.
Thank you.
That should be top, not below.
Yes, I will correct it later.
Remember, the figure is this style. Figure and the table is totally opposite. Fine?
Okay, the table should be on top.
Okay.
Thank
Do you
you.
have anything else? Okay, that's all from Kyoto. Yeah, please, NTU.
Yeah, NTU. Yeah, please.
Thank you for your presentation. Can you jump to their objective? Jump to their objective. The slides. Objective. Their goal.
Sorry.
Page 2.
Page 2?
Yes.
Okay. Okay.
Oh, sorry, page 3. Yes. So they want to detect the strawberry flower instead of the strawberry fruit.
They detect 3 types of strawberry. One is flower. The another is matured fruit and immatured fruit.
Also, they want to make sure the fruit, the number of fruit. Why they want to detect the flower?
I think if they can detect flowers after several weeks, it becomes fruit. So I think it's worth detecting.
Okay. Okay. Thank you.
Thank you.
Okay, thank you for your presentation. And I want to know why he chose the deep learning method as faster ASEAN instead of like ASEAN or YOLO.
Sorry, you mean why do I choose a deep learning method?
Why choose the faster ASEAN instead of like YOLO V3 or another?
One reason is in this research, our CNN method is effective for detecting or counting. So I'm interested in the fact, and another is I'm I'm interested in the subject CNN method. So I searched for research about CNN method.
Okay, thank you.
Thank you.
Okay, that's all from NTU.
Okay, thank you very much. Discussion. We'd like to move to the next presenter from Kyoto. Just a set, sending the material from Kyoto to you.
Can you stop sending materials? Tsukuba. Okay, thank you.
Can you see our materials, NTU and Tsukuba?
Yes, you can see.
Okay, good.
Yes.
NTU also.
Yes.
All right, thank you very much. Matsumura-kun, ready? Okay, 10 minutes presentation. Go ahead.
Sorry, we can't hear you.
Sorry. Hi, my name is Fumiki Matsumura, and I'm going to talk about volume measurement objects underwater using Helmholtz resonance. First of all, I apologize for changing my title of presentation slightly. I intended to fish volume measurement. However, the research on it was not available yet online, so I'm going to the previous research of fish volume measurement. They use other objects here for volume measurement using Helmholtz resonance. So I'm going to talk about background information about this research. First of all, it has been said the world population has been increasing year by year, and it is estimated to be more than 9 billion in 2050. So proportionately, the food demand increases. However, the 90% of fish population is now currently free fished or overfished. So the catching the fish in the ocean has reached its limit, and it's not possible to get more fish out of water. So fish farming, which means raising fish commercially in fish ponds or tanks, could be an effective option. However, since information technology such as using computers or internet has not been applied in fishery industry enough when compared to other fields of agriculture. So currently it's difficult to determine when to ship the fish, or other problem is overfeeding, which means remains of fish food could contaminate the water and the environment. So we need a measurement of objects, methods to measure the objects underwater. So okay, how? Traditionally, liquid displacement method has been conducted. It's simple, just bring fish out of water and measure its volume or size and put them back in the water. But this is time consuming, and it is difficult to be conducted in large production facilities, and it could be also destructive. So it means in this method, they could hurt fish body. So another example is using underwater camera systems. It is method to use image taken in water to measure the volume of fish. However, this is expensive and time consuming. It's not available in murky water. So when the water is unclear, it's difficult to get a clear image of the fish. So we can't distinguish the fish from the image. So we need a new measurement technique, and they use a method called Helmholtz resonance for this research. And it is rapid and non-invasive. So I'm going to talk about the mechanism of Helmholtz resonance. This time I'm taking the example of the plastic bottle. When you blow air close to the neck of the bottle, the certain sound come out from the bottle. Interestingly, the tone of the sound changes according to the amount of objects in the bottle. So if there is a small amount of water in the bottle, the tone come up from the bottle will be low. And if there's a large amount of water in the bottle, the tone come up from the bottle will be high. So we can get the frequency of the sound. We can get measure the volume of objects in the bottle. Here's a method they use in this experiment. Instead of blowing air across the neck of the bottle, they use a water pump and the edge to generate the sound, and resonance is caused. And here, there's a microphone to catch resonance. And the sound codes in the microphone will send to computers to get the frequency. And here's an equation to calculate the volume of objects using frequency. So in this research, they compared the actual volume of the objects and calculated volume of objects. And this time, they used two types of sample. One is air bubbles, which is example of objects less dense than water. It's also a model of air-filled fish bladder, which means ukibukuro in Japanese. And they also used glass bowl. It's an example of objects denser than water. And also, they use two types of resonators. One is open cavity, which has a hole in the resonators, and the other is closed cavity, which doesn't have the hole in the resonators. Then I'm going to show the results. This is a result of frequency and volumes of objects. Now, on the left-hand side, it's a volume of glass and frequency. As volume of glass balls increases, the frequency increases. However, on the right-hand side, it's a result of air bubbles. For air bubbles, as the volume of air increases, the frequency would decrease. This is happening because there's kind of energy loss in the bottle. And this is results of closed cavity, predicted volume and actual volume of objects. As you can see, the predicted volume and actual volume are matched. And this is a result of open cavity. Also, the predicted volume and actual volume are matched. So, in conclusion, using a Helmholtz resonance, we can measure the volume of objects in water accurately. So now this time they use glass ball and air bubbles. However, this in future it could be applied to measure volumes of fish without invasion. However, this has several problems. One is that this time they think the fish bladder to be spherical, but actual fish bladder is not spherical, and this research is now ongoing. Thank you, and this is references.
Thank you for your presentation. I have one question. Why do the resonators need a cavity when experiment of measuring the volume of objects in water?
For future application, they need a kind of entrance for fish to go into the resonator or go out from the resonator. So this is why I think this is why they made a kind of hole in the resonator.
Thank you.
Okay, go ahead.
I remember you said that 90% of fish population is overfished at the beginning of presentation, and I wonder what's the definition of population in this context.
Oh, sorry. I'm not. I'm not sure. I think I suppose it's kind of available fish for eating.
I see. Thank you.
Another one? Anyone? That's all? Okay, that's all from Kyoto. Please, NTU.
So, questions? Yeah, please.
Thank you for your presentation. I have one question. What is the challenge they encountered? What is the challenge in this research?
You mean object? Objective?
No. The challenge.
Challenge. because I didn't do this research, of course. So, but I think the I think the calculate the predicted volume of objects should be hard. Is it okay?
Okay, thank you.
More questions?
Hi, thank you for your presentation. I would like you to ask if this kind of resonance is harmless to the fish.
I think so, but it could have some effects on fish.
Thank you.
Yeah. One more questions, yeah, please.
Thank you for your presentation. I'm curious about which hardware do you need to implement this research?
Sorry, huh? Which one?
Hardware. I mean, how do you start a machine to get your information? Maybe you need a camera to get image like this.
Okay. They use pump and edge, so the water is pumped toward the edge, and at the edge it kind of sound generated.
Okay, thank you.
So that's all from NTU.
Tsukuba, please.
Thank you for your presentation. In your article, did they mention how they move the fish to the experiment device, the box?
In this research, they didn't use the fish.
Yeah, yeah, thank you. And so, in the future, what do you think they move fish to the box?
I think one thing I thought was to use some food for attracting them.
Okay, thank you.
Hello, good morning. Thank you for your presentation. I want to ask if the researchers mentioned about the cost of the device and how do you compare it with like the imaging system that you mentioned earlier?
Sorry, in this research they didn't compare the image systems and this Helmholtz resonance methods. They just kind of mentioned it as a kind of the methods currently conducted.
How about the cost also? They did not mention. Sorry.
Cost?
Yes.
Cost for this method?
Yes.
I'm not sure, but I believe it would be cheaper than other methods.
Okay, thank you very much.
Okay, that's all. Imi-chan is okay?
Yes.
Okay. Okay, thank you very much. All your discussion. Next would be who's the next? Presenter. Our next Kyoto. Tanaka-san? Tanaka Rina-san.
Okay, hello everyone. I'm Lina Tanaka from Kyoto University. Today I'm talking about bioplastics from vegetable waste. Here's the contents of today's presentation. First, I'll introduce you what bioplastics are. After that, I'll show you the methods for production of films. Then I'll move on to the result, then wrap up with conclusion. Okay, first of all, I tell you the reasons why I chose this topic. The reason that's because the plastic waste is one of the most serious environmental problems in the world. And for example, I show you this article that says that Indonesia sent back the waste from other countries. Not only Indonesia, but also many other Eastern Asian countries sent back many waste from other countries because they are suffering from the shortage of dumping land. Because China has recently completely banned imports of the waste. And this picture is about the Caribbean Sea, that you can see a lot of plastic waste floating out on the water. And it is reported that only 1/3 of the plastic are recycled now. And there are many resolutions suggested to tackle this kind of problem. And one of them is bioplastic. They are plastic made from organic resources. For example, when you go to Disneyland, you can get these kinds of plastic bags. And on this bag, it is said like this. This plastic bag partly contains polyethylene made from sugar canes. Not only the Oriental Land, but also many other companies has already started introducing bioplastics because they are biodegradable and unlikely to burn. And in this research, the researchers used vegetable waste for the bioplastics instead of sugar canes in this case. And the another point of this research is that they use less energy than the conventional method. Okay, so how they made plastics from vegetables? Basically, we can get plastics a kind of plastic from sugar after condensation and esterification with alcohol. And to be honest, I'm not so good at chemicals, but in this paper, it is said that cellulose and non-soluble pectin compose a film, and soluble pectin and sugar act as a plasticizer. In other words, they make the film softer. And in this research, researchers got vegetable powders from vegetable processor companies and put them into the HCl water solution, and they stirred them on a hot plate at 40 degrees. After 12 hours, they strained the liquid through the filter and then dialyzed, then dry them for 72 hours on a plastic dish. Okay. Then in result, they can successfully got the homogeneous films as the plastic. And they used 4 kinds of vegetables: carrot, parsley, radicchio, and cauliflower. And the most attractive point of bioplastic is that they are biodegradable. So they tested using BOD because seawater organisms consume oxygen when they distract the film. And this number, rapid decomposition, begins after 2 days and more rapidly after 15 days, shows that they degrade more quicklier than other bioplastics. And also, researchers tested their capability as plastics with these criteria: strength, food contamination from bioplastic, interaction with water, and gas barrier properties. As for the strength, this left side graph shows the results of the 4 films, and I put the right graph for your reference. Vertical axis shows that how strongly they pull the film, and horizontal axis shows that how long the film was extended. So if the graph is like this, red line brittle polymer, it shows that it is likely to break easily. And if the graph is like this, elastomer, so elastic polymer, it behaves like a rubber. Then when you compare this graph and this graph, you can see that all the 4 films behave like plastic or elastomer. And on the whole, the researchers said that the mechanical properties of these films are similar to other bioplastics, and they are relatively stronger and less stretchable than others. And they also tested that whether the ingredients of the films migrate to the food or not. And the film was put with stimulant food for 2 hours about 70 degrees. And as this table shows that all the bioplastics have migration well below the EU limit for food security. And they observed the contact angles with water over time. In this experiment, the contact angle is equal to the water repellent, so they can test that the film can prevent water from going through the film. And this image is a droplet of water on a carrot film. Then, according to this paper, the contact angle depends highly on the amount of cellulose. So when you see this graph, you can understand that the carrot, this black line, which have the highest amount of cellulose, shows the complete hydrophobic character. Okay, the last criteria is gas barrier properties. They tested that whether the film can protect oxygen from going through that film. And they used 3 kinds of materials. The bioplastics from pure carrot, and PVA, it is polyvinyl alcohol, which is a kind of relatively soft plastic, and a mixture of carrot film with PVA. Then you can see that when we mix the carrot film with PVA, the oxygen permeability greatly improved by about 30% of the pure carrot bioplastic film. Okay, lastly, conclusion. So the researchers could get the acceptable bioplastics from vegetable waste with less energy, and they have characteristic of biodegradability and hydrophobicity. And they also found that when they blend with other materials, they can perform more greatly. And in the paper, the researchers said that this results proves that we can expand the application of bioplastics. For example, we can also use them for food packaging. Okay, thank you for your attention. This is bibliography and image credit.
Thank you for presentation. This conclusion presentation. What food package is suitable or bioplastics from vegetable waste? Do you think?
What kind of
food is suitable
for the food packaging?
Bioplastics is used for what kinds of food?
Actually, the bioplastic in this paper, it doesn't mention about the actual but practical usage of bioplastics for food packaging. They just hope that in the future they can be used for other usage like food packaging. Yes, so as long as I know that the bioplastic film has not been introduced as food packaging.
Okay, thank you.
Go ahead.
I have one question.
Yes.
Is it possible to make the plastic with the bioplastic 100%, or is it just a part of the plastic, like 50%?
Yes, in this research, they firstly made 100% bioplastic, but the characteristic or practical characteristic of them is not enough to use as the other plastics, chemical plastics. So now it is more practical to think that mix them with other materials. And for example, this PVA films, it has is relatively biodegradable. So if they mix them with other, eco-friendly materials, we can get more environmental materials with bioplastics.
So that PVA film is bioplastic, kind of. No,
No,
but
it
eco-friendly.
is, yeah, it is easily decomposed on the water.
Okay, thank you.
Anyone else? Okay. Okay, that's all from Kyoto. Please, NTU.
So questions from NTU. Okay, wait.
Oh, thank you for your presentation.
Yes.
Is it possible to use this method for every vegetable, or it has some limit when you're choosing the material?
Did you say that every material?
Is it has any limit when you're choosing the material to make the bioplastic?
So as for the ingredients of the to make or to produce the bioplastics. Okay. So to be honest, I don't have much knowledge about producing producing plastics, but it is said that in this bioplastic, cellulose compose a film, and pectin and sugar act as a plasticizer. So it's just my opinion, but we need at least cellulose or pectin and sugar to produce plastic film. And is it enough? Is it enough to answer your question?
Thanks for your presentation. And I have a question about how high temperature could bioplastic can suffer? Because if I want to put hot food or hot drink, will it cause too high temperature will melt the bioplastic?
So about the behavior of the bioplastic at very high temperature, I didn't I can't find on this paper. So
Okay. Okay.
Sorry, but I couldn't
okay.
find any.
Okay, that's fine.
Sorry. Thank you very
Thank
much.
you.
Okay, thank you for your presentation. I was wondering, does the bioplastic cost much more than the plastic? And do you think that will fully replace, fully used in the public? Thank you.
Okay. So about the cost of bioplastics, I couldn't find any mention on this paper, but only as for the ingredients for the plastic, in this research they use the vegetable waste from food processor companies. So we can expect that the cost will lower by using food waste. And another question is about that whether this bioplastic can completely be alternatives of the conventional plastics. And it's just my opinion, but to tackle this problems of the lack of dumping place or save the environment on the earth. It is not the best just to replace all the films with bioplastics, and moreover, we can't expect the very high qualities for bioplastics than the conventional films. So in my opinion, we should mix, and we should, how do I say, we should distinguish how where we should use the bioplastic and the conventional plastic. And the most important thing is to reduce the usage or consumption of plastic on the whole.
Great, thank you.
This is out of my own curiosity, but is there any downsides of bioplastic compared to conventional plastic bags we use on a daily basis?
So are you asking about another example of a bioplastic in?
No, I'm asking about is there any downsides of a bioplastic compared to conventional plastic bags? Like, is there something that a plastic bag does better that bioplastics do not have?
Sure. Yes. Using them. Okay. Yes, when I researched about the usage of bioplastic bag, I found that another companies like Ion in Japan used the bioplastic as a plastic bag, and as I told here, the attractive points of bioplastics are biodegradable and unlikely to burn. And in addition to these points, in my opinion, if the company use the bioplastic, they can sell themselves like very eco-friendly companies or like that. So they can. So the using of bioplastic can also contribute to the image of the image of the companies or productions. So I don't know the exact reasons why they use bioplastic, but I suggest these reasons for you.
Okay, thank you. Okay,
that's all from NTU. Let's move to University of Tsukuba.
Thank you for your presentation. When they produce plastic, they need sugar, right? And I guess vegetable don't have much sugar compared to other crops. Mm-hmm. And did the article mention why they use vegetable waste?
Mm-hmm. One of the reasons why they chose the vegetable waste is that they want to decrease the amount of food waste, and it is said that there is a kind of plastic that is made from cellulose, and vegetable has some amount of cellulose, so maybe they focused on the cellulose and the sugar in the vegetable waste.
Mm-hmm. Thank you.
So in the slides, it said that they got the bioplastic from carrots and parsley and stuff. Did they make the bioplastics with just one vegetable, or do you think they can use a mixture of different vegetables to make the bioplastic?
Okay. In this research, they use full vegetables and they didn't mix them. They just made each plastic using full vegetables.
But do you think it can be made with a mixture? Because you said they would be getting it from like waste, vegetable waste.
Yes.
And it might not necessarily be just carrot waste. So.
Yes, in my opinion, they can be mixed. But when we see the result of a strength like this, or okay, this one, you know that the carrot behaved the most the better characteristics for the bioplastics. So it depends highly on which vegetable we use, but it is possible, I think.
Thank you.
Thank you for your presentation. Can I see the former slides?
Former slide. No, this one.
Sorry, later.
Later one. What kind of slides do you want to see?
You said bioplastic dissolved into liquid.
Yes.
Yeah.
Yes, as this slide shows that they are decomposed in the water after 2 days, and the speed of the biodegradation increases after 15 days. Is that okay?
Is there figures showing the amount of dissolved plastic?
So you are asking about whether the film is completely dissolved or partly dissolved. Is that right?
I think the former one.
Yes.
Sorry, can I see the former slide?
Which one? Do you say this page number of what you want to see?
Maybe 7. This, yeah, here it is. It says bioplastic dissolved this amount into liquid.
This table just see that whether the component of the film migrate to the food. So they test like this in case of they use bioplastic for food packaging and whether the food security is good or not.
Do you know how long have biosphere bioplastic have reacted to this food?
Reacted to food. Okay. Sorry. Yes. In this experiment, they put the film with stimulant food for 2 hours at 70 degrees Celsius.
Thank you.
It's okay. Time already up. Fine.
Yeah, that's all from Scuba.
Okay, thank you very much.
Thank you very
Yeah,
much.
thank you. Very nice discussion. Very long. Maybe they are very much interested in that. Okay, final presenter would be from NTU.
Can you see the slide? Scuba and KU?
No, not yet.
No.
Okay.
Yes.
Okay. Hello, everyone. I'm Lin Zhewei from NTU. Today, I'm going to introduce about a topic, near-infrared imaging to detect aspergillus flaves infection in 3 varieties of dates. So here's the authors. Yeah. So first, I want to talk about what is the date fruit. It is a popular fruit in Middle Eastern countries, and has a very high energy for people to consuming, and nice nutrition content, and also low fat and zero cholesterol. So the plants will look like this, and here's the fruit looks like. This one is the crispy, crunchy one, and cut it into half will look like this. And the soft one without the skin, also the soft one look like that. So why I want to do that? Because we know that aspergillus flaves is a mold that like to colonize on the grains, vegetables, and the nuts, and that will cause the human damage on the brain or the dent, also the allergy. So we want to use the non-destructive way to classify the dates has a good quality or not. So as for the material and method, we pick 3 types of dates. First is the fard, and the kalahas, and the naghal. And each fard we pick 45 and 450 samples for that, and do the 3 kinds of treatment. The first one is the untreated control, and that means we didn't do anything on that, so we put it on the room temperature. And the stereo control, so we clean out their surface and resin it, and get it into dry. Also, the infest is the sample. So we done the same thing as like the SC, but we done some inoculated treatment for that. So here's the chemical we use for the surface, the sterilized. And this is the liquid we used for inoculated. So as for the infested samples, we recorded every 2 days and recorded the growth for 10 days. So that will have 5 samples for that. So the total samples will be UC for 1, and SC for 1, and IS for 5. And all put IS samples into the environmental chamber. And the weather condition will be 30 Celsius and 85% relative humid. So here's the instruments we have. The first one is the camera. We use the NIR camera for detection, and also the lamps, and the analyze and image accounting system. And we use 2 kinds of software, MATLAB and the SAS software to analyze it. And we pick up the significant wavelengths and some features of the dates to analyze. And also we put the samples on the displays. And the wavelength range will be 900 to 1700. And as for the physical properties, we measured the moisture content, and here's the machine we have. And also the water activity that has a highly related to the bacteria activity. Here comes the result. We can see that the untreated control for the moisture doesn't vary a lot, and the sterile control doesn't vary a lot. But for the IS, they changes a lot due to the moths growing. So in the beginning, that you can see there is lots of changes from 10 days. And also the water activities, we can see the similar consequence that untreated control doesn't vary a lot, but for the IS varies a lot. And also the mean gray value for the NIR data, we can see untreated control varies a lot, and the sterile control doesn't. IS not that big. So here's the result we have. We focusing on the untreated control and the fungal infection, that is the UC and IS, and use the LDA, QDA to analyze it, and we got the accuracy, classification accuracy, like this. And for this sterile control and the fungal infection, that we have the data classification accuracy for that. So here's the conclusion. The NIR system from 900 to 1700 nanometer can classify the varieties of the date, and the histogram features and the histogram group features will have the most significant features to classify it. And it can classify the accuracy up to 96 to 90% accuracy. Here's the reference. Thanks for listening. Thank you.
No questions, please.
Thanks for your presentation. And I have one question is, what disease will caused by uh, aspergillus flavors?
Pardon.
What disease will caused by aspergillus flavors?
Because it's a mold that will cause the human allergy, and if that more seriously infection, that will cause your brain and lens damage for this mold.
Thank you.
Okay. Due to the time, that's the end of the NTU. Let's move to University of Tsukuba.
Thank you very much for a nice presentation. So about the moisture content of the dried fruits, like moistures, sometimes when it is not properly dried, right? Okay. There are 450 samples, especially for, did you find the difficulties if the moisture content varies much? For example, if it is dry, sometimes inside very soft, sometimes it is not well dried. So in that case, is that as much influence on the results or not?
Pardon, could you please say that again?
The questions about the moisture content is water content. The water content of the dates, for example, in the experiments, 450 samples were done, right? For example, if the moisture content varies, do you have any examples that they have checked with the moisture content, right? 10% moisture content, 6% moisture content, or 5% moisture content?
I think in this paper they didn't show the details about the moisture content, but this is the only picture data I can give you, and we can see that for IS that has changes a lot for the moisture content, but for UC and SC doesn't.
I see. Okay. Yeah. Thank you very much.
Thank you.
Any question from Tsukuba? Yeah, I think that's all from Tsukuba. Thank you very much.
Okay, Kyoto, anyone?
Thank you for your presentation. I have one question, and you showed some changes like this graph shows, and these changes are caused by this amount of Aspergillus flavus. Sorry, I couldn't get why this graph changed.
You say the moisture content changed?
Yes.
Oh, because we put it in this environmental chamber. Then, if the mold growing, that will infect the moisture content.
Then what's the relation between Aspergillus flavus and this experiment? Sorry, I couldn't get.
Okay, could you please say that again?
Sorry, what's the relationship between Aspergillus flavus and this experiment? What's that? Sorry.
水跟那个水跟哦，水跟那个多少？Oh, you say the relationship between the moisture and the NIR spectrum?
Yes.
Oh, I see. So, in this paper, they didn't done that research. They have, this is the NIR data for that. And they use the MATLAB to analyze the significant wavelengths and have the mean gradient value. So they didn't compare the moisture content and the NIR data together. Yeah.
Okay, thank you. Okay, fine. Anyone? Okay. Final question.
Oh, hello. My name is Hiroki Tamara, and can you go over to the slide number 4? Yes. Oh, sorry, slide number 5.
5?
Oh, this slide.
This one.
Yes. And I have one question about this picture. Why did you use the two halogen lamps to do this experiment?
You say the lamp?
Yes, why did you use lamps?
Why did I use this lamp?
Lamps.
Lamp? The third and second and third one, this one?
Oh, you use two halogen lamps, right?
Yes.
Why did you use these lamps?
Why did I use this one? Because in several papers they says this kinds of lamp will give the best result for the NIR system.
I see. Thank you very much.
Oh, thank you.
Okay, that would be all from Kyoto. Okay, today that is all presenters and discussions. Thank you very much your cooperation. Bye.